Alright, so hello everyone. So I do want to apologize for the lack of uploads. I hope everybody's doing well. I'm so sorry if I haven't uploaded in a long time, like in probably 3 weeks. I've just been really busy with just, a lot of things. And but I am back. So I wanted to go ahead and go over this problem. Now, this is, about angle between two vectors. So we're going to do two of these problems. So it says determine the angle between the two given vectors and then graph both vectors and label the angle between them. What I mean by graph it is like literally draw it out on the coordinate plane. So what I'm going to do is I'm first going to try and draw the coordinate plane really quick. I'm going to do that off camera. Give me 1 second, guys. Alright, guys. I went ahead and drew the Cartesian plane. I'm actually gonna just copy and paste this. So I don't have to... Well, I'll copy it and then I'll paste it. I'll copy it and paste it I'll copy it for now and then paste it whenever we go to the next example. I hope y'all can hear me okay. So the first question says, and we're gonna work on part A here. So give me a second, let me move this lower. Okay, sorry about that, guys. So like I said, what I'm gonna do, so we're first looking at the first one. So let's look at part A. We're given the vector u equals -2, -3. So I'm just gonna, and I'm gonna start at the origin, guys. So I'm gonna start, you always start at the origin when you're drawing a vector. So we have, and then so we have this going on, which is -2. So it's -2, -3. Hold on. So I'm gonna just like put a little arrow there to indicate that that is my first vector. And I'm gonna just draw an arrow the best way that I can. And then, so this is vector -2, -3. This is, I'm gonna call this vector u. Okay. And then for vector v, we have 4, -1. So I'm just gonna put, and I forgot to put the little arrow symbol. I really don't know if that's how you do the arrow symbol for vector, but I'm just putting it like that. The next one is 4, -1. So let me make sure that it's, you can hear me. Okay. So vector v is over here. So I'm just gonna put it, I'll put a little arrow pointing this way. So I'll just put a vector or a line going through here, and it should look something like that. Right. Now, for this first one, we want to find the angle between these two vectors. So again, we're just looking for this angle theta, okay? And so the way that this is gonna go, there is a formula that we're using. So I forgot what it was. Oh my goodness. Hold on, guys. Hold on. Okay, guys. So the idea is, and we're gonna go ahead and do, so I'm not gonna draw like the other lines and make a triangle like that. We're just looking at these two vectors, okay? So the angle between two vectors, I'll call them u and v. So u and v, okay, is gonna be cosine of theta is equal to u dot v hold on guys, give me a second. Alright guys, sorry, I keep pausing and I'm so sorry about that. Okay, so here we're gonna go ahead and we have our two vectors here. We have 4, -1, so here's 4, -1 right over here. And we need to find u dot v. So u dot v, so really what this comes down to, we're gonna do cosine of theta is u dot v, so u dot v, right? And actually, what I wanna emphasize, guys, is so u is equal to the vector -2, -3, and v is equal to the vector 4, -1. So if y'all don't know how to do dot products, I can make a video on that, but basically you're gonna u dot v is equal to, it's gonna be u1, so -2, which is u1, and then v1, which is 4, so times 4, v1, plus, and then u2 is going to be -3, right? So u2, and then times v2, so v2 is -1. Okay, so this is going to go -8 plus 3, which is equal to -5. So we know that u dot v is -5. So you know that this is, you know what this is. I'm sorry guys, hold on. So we're now going to find the magnitude of u and v. So you want to remember that when we have a vector a comma b, if vector u equals a comma b, then the magnitude of u, is equal to, which this is the label we use, the notation we use for magnitude. It's gonna be the square root of a squared plus b squared. In other words, the Pythagorean theorem. Okay, so in other words, we know that the magnitude of u, so I know that again, for the magnitude, it's going to be the magnitude of u is equal to the square root of the quantity, and it's going to be -2 quantity squared plus -3 quantity squared, okay? And this will end up giving us the square root of 13, if I'm correct. So I know that the magnitude of u is the square root of 13. So I know that for this, we're going to put the square root of 13. Okay. I'm trying my best to label as much as I can, guys. Just try to follow along what I'm doing. This is what the magnitude of u is, okay? And then the magnitude of v, you're going to do the same thing. So Pythagorean theorem, it's going to be the magnitude of v, which is equal to the square root of 4 squared plus -1 squared. Okay. Which was equal to 16, so it's equal to the square root of 17, really. So I know that so this would be, again, the magnitude of u. I just want to be very clear, guys. This would be the magnitude of v, so this times the square root of 17, I think is what it was. So I just want to emphasize this. I'm sorry if, like, I keep trying to be very clear. So cosine of theta will be equal to negative 5 over the square root of 13 times 17, which is equal to negative 5 over the square root of 221. Now, so I know that that's what cosine of theta is equal to. You don't have to necessarily, like, make it so that, we, so that it rationalizes out. You can just go ahead and do the cosine inverse of this entire thing. So the cosine inverse of the quantity negative 5 over the square root of 221. So in other words, the cosine inverse of, and let me use a different color, cosine inverse of cosine of theta. So solving for theta, cosine inverse of cosine of theta is equal to cosine inverse of negative 5 over the square root of 221. When I do that, my angle, so these two cancel out, theta will be approximately 109.6 degrees. Actually, 109.7 degrees. If you want to round it to the nearest, so this is to the nearest 10th. And then you want to go out, and if you want to do it as to the nearest whole number, it would be approximately 110 degrees to the nearest whole number. It depends on what they ask you to round it to, guys, but that is what the angle theta is between these two vectors. So therefore this is approximately 110 degrees, or 109.7 degrees if you want to round it to the nearest 10th. We're going to go over one more, guys, just for the sake of it. So what I'm going to do is I'm going to just try and draw out the vector and on the Cartesian plane instead of actually drawing it just like I did for the first example. I'm just going to skip that part and we're going to get right into how to find the angle between the two vectors. So give me 1 second, guys. I'll be right back. Alright, guys, so this is going to be the last one. We want to find the angle between these two vectors. So this is going to be the last one I'm going to do in this video. So here, what we're going to do, we're going to go ahead and label the two vectors. So the first vector is -2, -7. That's vector v. So it should be about right here, if I'm correct. So that is that one. And also remember, guys, we're gonna start at the origin. So we're gonna start right here. And what I'm gonna do is I'm gonna label here the lines. So hopefully I can draw it right. Okay, well, give me a second, guys. Alright, guys, okay, so I forgot to label the second vector, but here. This is, oh, I'm sorry, this was supposed to be u. I'm sorry guys, this is supposed to be u, and this is supposed to be v. Alright. Now, we need to find again the angle between these two vectors. So look, this is the angle we're looking for here. Call it angle theta. And again, we're going to use the formula that the cosine of theta is really equal to, I think, what was it again? I think it was u dot v magnitude u over magnitude u magnitude v. Yeah. So u dot v, so again, we're just going to go ahead and do this. U dot v over, hold on guys, hold on. Alright guys, so we're just going to do the dot product of u and v, so u is -2, -7, so this dot v, so dot the other one, which is 2, -5, right? It's the other one. And then over, okay, and then over, and again, we're gonna do remember that the magnitude of u is the square root of a squared plus b squared if vector u is equal to a comma b. So I want to reiterate that, guys. We're just doing the first one squared plus the second one squared. So -2 squared plus 7 squared, and then times, and then the square root of 2 squared plus -5 squared, which is equal to, and again, we're going to use, again, u1 v1 plus u2 v2, so it's going to go -2 times 2, right? So this times this, plus -7, this, times -5. So you really want to understand dot product, guys. You really want to understand dot product. Over the square root of 4 plus 49 times the square root of 4 plus 25, which is really -4 minus, I'm sorry, -4 plus 35 over the square root of 53 times the square root of 29. Okay. At this point, guys, we're really not gonna simplify the square root of 53 or square root of 29. Just multiply them. So really, this is equal to 31 over the square root of 1537. Now what you're gonna do is you're gonna say, so therefore, thus, we get cosine of theta is equal to 31 over the square root of 1537. Now again, we're just gonna do the cosine inverse, so cosine inverse of cosine of theta of cosine of theta is equal to the cosine inverse of 31 over the square root of 1537. Oops. And so we know that to solve for theta, we're just going to put that in the calculator. We end up with cosine inverse, and we're going to do the square root of, so 31 over square root of 1537. Hopefully it gives me an answer. And so therefore we know that the angle theta in positive degrees, guys, because we need it to be in positive degrees, is going to be approximately. So theta is approximately 37.7 degrees. If you want to round it to the, so this is to the nearest tenth. If y'all want to the nearest hundredth, theta is approximately 37.75 degrees. So this is to the nearest hundredth. And then finally, theta is approximately, and it would be 38 degrees if you want to round it to the nearest whole number. So to the nearest whole number. Or whole degree, right? These are 3 different answers, guys. If it depends on what they want you to round it to, but these are 3 different, depends on what, if the problem asks you to do it to the nearest tenth, nearest hundredth, nearest thousandth, nearest whole degree, that would be how you would do this. So that is going to be it for this video, guys. So we can, obviously, looking at this, we can say that this is approximately 38 degrees, if anything. So this angle here would be 38 degrees. So that is how you find the angle between 2 vectors, guys. I do apologize if this video was pretty lengthy. I apologize for the pauses. But if anybody has any questions whatsoever, please let me know. And thank y'all so much for watching. And please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.